Welcome to the project demonstration of solar based seed dryer. So with hot air blowing from this evacuated vacuum tubes. So the main purpose and flow of this project is, so here in this chamber we are going to place the seeds for drying purpose. If they are wet, so as we know that the seeds will not provide the lifetime of the seeds will be decreased. So in order to maintain the lifetime, then we should place a hot chamber for the seeds. So this is going to be the hot chamber with exhaust fan, and in this chamber we are going to provide the hot air from this evacuated vacuum tubes. So from here the air will be provided inlet, and this is the outlet all over the pipe, and the outlet is fed to the inside this chamber. So with help of this exhaust fan, so they always trying to fill this chamber with air. So the chamber will get the air from this pipe, and this pipe will get the air from the travel all the through the pipes, copper pipes. So when we place this chamber outside under the sunlight, so due to the sunlight heat, the copper tubes will be getting heated, and parallelly inside the copper tubes the air will get heated up, and then that particular air will get directed by this exhaust fan into this chamber. So there we are going to use two temperature sensors. Those are all DS18B temperature sensors. So that temperature will be continuously monitored by our Arduino Uno board on the LCD display, and also blink application with help of this ESP8266 module. So from this blink application we can control the exhaust fan. So if the particular temperature got reached, and if you don't want to work this module, so then you can just on and off the motor which is inside the chamber, and that will be controlled through this electromagnetic relay. The whole system driven by this 12 volt 1 amp battery. So as we observed, there is 3 batteries are connected in series. So each battery of 4 volt 1 amp, so that we will get 12 volt 1 amp, which is a rechargeable battery. So in our project we can recharge the battery from the solar panel directly, but if there is no sunlight, if you want to charge a battery from the grid, just connect the transformer at here wrote T, and for the solar panel we wrote S. So if you want to charge a battery from the grid, so then connect the T at T or S slot here, and switch on the charger. There we get the light indication on the charger. So it will be fully charged with a duration of 10 hours, either grid or solar panel, both are same current provided voltage with. And after that, if you want to charge a battery now solar panel, in the final project execution, just connect the solar panel here. So this is a charging circuit, so which will take a DC as well as AC, as we are providing the 4 diodes as a bridge rectifier. So if you provide the transformer, this transformer will to the volts AC input and provide the 12 volts AC output. So that is input to the charging circuit. That AC will be converted into DC with the help of this bridge rectifier as well as the capacitor smoothing purpose. And if we provide the DC input from the solar panel, then this bridge rectifier will act as a polarity corrector. So if you make the wrong connection, the polarity reverse connection from the solar panel, then this bridge rectifier will rectify that in plus and minus, so that will be polarity matches with the battery. And this one is the main on off switch for the whole circuit board. Okay, so then we have interfacing connections. The relay connected 12th pin, and ESP8266H pin number 8 and 9, and DS18B20 temperature sensor connected 6 and 7, and A0 to A5 connected to the LCD module. Okay, so the main flow is air inlet, air heat up when we place this under the sunlight. So the air will be directed by this exhaust fan into the chamber. So means we are pulling the air from all through this evacuated vacuum tubes, copper tubes, to the chamber directly with help of this exhaust fan, and then parallelly we are getting heat up. And for confirmation purpose, we are going to continuously monitor the in temperature and out temperature and controlling of the fan. And also we will get the notification alerts whenever the chamber temperature is heated maximum of 50 degrees centigrade. When it crosses the 50 degrees centigrade, then we will get the audible alerts into the our mobile phone application. So before execution of this final demonstration, just we need to on the hotspot in your phone, means change the hotspot name to project 4842 without any space, without any capital letter, and the password should be 129. Right? After changing the hotspot settings on the hotspot and data, so there we can see one red icon, it's showing that the device is offline. Right? So now I'm going to switch on the kit. So after the device connected to the right, now the red mark was gone. So right, after the system got connected, just restart this Uno board by press and release this switch. So there we can control the, initially the motor will get switched on. You can off that by sending the commands to the Wi-Fi module receiver kit. So let us demonstrate this device under the sunlight directly. Right. So as you can observe that relay got switched on, there is a light indication on the relay board as well as the fan also visualized on and off status. So let us go with the demonstration under the sunlight. So right, so now we can observe that the inside temperature on the LCD screen is inside the chamber. So we kept this for at least 5 minutes. So in that time only the temperature inside the chamber increased to 40 degrees centigrade, but outside the temperature, so outside temperature was placed under this LCD display. So to get the exact environment temperature, but inside the temperature we can see that. So now we can control the fan. So it's got switched on and it's pulling the air from the chamber outside. The chamber will get the inlet from this evacuated vacuum tubes. So as we can see the temperature difference also. So let us wait for some more time so that we will get the more temperature increase in the chamber, inside the chamber. So inside chamber we set the temperature for 80 degrees centigrade, 50 degrees centigrade. So when it reaches that, then automatically the chamber fan will get switched off, or else we can control it manually. So if you don't want to control that, so it's keep on increasing. Right.